Okay guys, let me go over this test with you, explaining each problem. So number one, it says name all of the subsets of the real number 0. So I'm always deciding, is a number rational or irrational? By definition, rational means it can be written as a fraction, and irrational means it cannot be written as a fraction. Okay, so the number 0 can be 0 over 1, so it's rational. Okay, it's an integer because integer are positive and negative numbers that have a decimal of 0.0, so it's an integer. It's a whole number because the whole numbers are exactly the same as the integer, but only 0 in the positive, so it is a whole number. And it's not a natural number because natural numbers don't include 0. So just those three. Okay, this one, it says name all the subsets of negative pi. Well, pi is irrational because it cannot be written as an exact decimal. We estimate it at 3.14. So whether it's negative or not, doesn't matter. It's irrational. And there are no other subsets under irrational. So if you call something irrational, you would never click any other box. So pi is irrational. Okay, this, subsets of this. Well, since it is a fraction, it's rational. So numbers are either rational or irrational. Could not be both rational and irrational. And rational means it can be written as a fraction. So if it can be written as we see that this is a fraction, so obviously it can be written as a fraction, so it's rational. And then it is the first choice under rational. Whoop, I went upside down there. What happened there? The first choice, went upside down. That was weird. The first choice under rational is integer, and this is not an integer because integers are positive and negative numbers that have a decimal of 0.0, and since negative 2/3 is 0.6 repeating, that doesn't have a decimal of 0.0, so it's only rational, no integer, no whole, no natural. Okay, this one. This one was tricky because it was basically the setup. So it says that Liz is driving 125 kilometers per 1 hour, and Tim, this one is Liz, and Tim is driving 80 miles per hour. And it says who's driving faster. So you have the choice, and then it gives you this factor. You have the choice to change kilometers into miles per hour and compare that. So if you changed kilometers to miles per hour, you'd need kilometers in the denominator and miles in the numerator, because you'd want to get left with miles per hour to see is that faster than 80 miles per hour. Well, you'd use this conversion factor, 1.61 in 1 mile. Okay, so I kind of looked to see, okay, is there one like this? And so then what we would need to do is we'd need to divide 125 divided by 61. Is there one that started with 125 kilometers? I see one. This one starts with 125 kilometers. And this one says, it says who's driving faster. This one says Liz is driving faster. This one says Tim is driving faster. But this one right here is not set up correctly because, look, the kilometers and the kilometers are not in a place of cross-reducing. This one right here, I do have kilometers and kilometers, so it's definitely not this one. I'll tell you what, it's not that one, because that doesn't even have the kilometers cross-reducing. This one would be good. The kilometers are cross-reducing, and it looks like my setup here, and I told you that. So that would cross-reduce, and we'd get 125 divided by 161. I said no matter what, you can trust the math. 125 divided by 161 is 77.6. So that's telling you that 125 kilometers is equal to 77.6 miles. And the setup was correct. The only other way I could have done it was 80 miles per hour, and I could have done my 1 mile, and I could have done 161 kilometers, and that would equal, because I would need my miles and my miles to cross-reduce. Okay. So this one is set up like this, where my miles and my miles is cross-reducing, and it equals 128. And because look at this one. This one right here, the miles and the kilometers is not. So that one is a definite no. Okay, so that one's a definite no. So what this one is saying is that, oh, look at this. This and the miles and miles cross-reduce like this. But look at the kilometers, and that one has miles. So that would have needed to be 128.8 kilometers. You had to cross-reduce the miles, so you can't get left with miles. You would need to get left with kilometers. So only this one works to show that Tim is going faster, because 125 kilometers equals 77.6 miles. So Liz is going 77.6 miles per hour, which is slower. So Tim's actually going faster. Okay. The other one that was, usually there's two that are pretty obvious that aren't correct, and that's A and D. B could have maybe looked correct, except for it didn't leave kilometers. If you want to change 80 miles per hour, you can't get left with 128 miles, because you wanted to change the miles to kilometers, and that didn't change it. That kept miles. Okay, on this one it says algebraic expression. That means no words, but just an expression here. It says 7 times the difference of x and 8. So if you do 7 times the difference of x and 8, the difference of x and 8 is 8 minus x, So we have an 8 minus x here, and we have an 8 minus x here, but if you want to say 7 times that, it has to be in parentheses. So you have to have the parentheses around the difference, and then 7 times that. Okay, you're buying candy bars for your classmates. Each candy bar is $2. Each candy bar X is $2, so you'd be spending 2x, and it said don't use the $. So it'd be 2x. So it says algebraic expression, so that's not words. So 2x is your answer for that one. How many classmates are you buying candy? Like, how many candy bars are you buying? I don't know. That's variable. You don't know how many candy bars because you don't know how many classmates. All I know is that it's $2 for each candy bar, and so depending on how many classmates, it'd be $2 times how many candy bars you need. But when you typed it in, it said not to put the $. Okay, so 2x, 2 times that. Select all the examples of an integer. Okay, so you only want to pick integers, so I'll tell you what. That's an integer, that's an integer, that's an integer. This equals -6, so that's an integer, because an integer has to have a decimal of 0.0. So that is not an integer. Okay, so it couldn't be that one, because that has a decimal 0.5, so that's not an integer. It has to be examples of an integer that's not a whole number. Okay, well, 5 is a whole number, 0 is a whole number, so we don't want that. We want numbers that are integers. We want an integer, but not whole. Okay, so 5 and 0 are integers, but those are whole, so we don't want those. Okay, so this is an integer. -6 is an integer that's not whole, and -4 is an integer that's not whole. So it's B and E. And D is not even an integer, so you don't want to pick that one. Number 8. Are integers always, sometimes, or never irrational? Well, we have rational numbers and we have irrational numbers, and integers are a part of rational. So are integers always, sometimes, or never irrational? Integers are never irrational. There's no subsets under irrational. So an integer is never irrational. If the product of 2 integers is negative, okay, so if you have 2 numbers, product means multiply. If 2 numbers are negative, okay, then, so if you have, well, let's do a number that would be easier to divide. Let's say 6. If 2 numbers are negative, right, if the product of 2 integers are negative, which means one of them has to be negative. So in order to get a product to be negative, one of these 2 has to be negative, not both. Then their quotient, then I would take those 2 numbers, then their quotient is always going to be negative. if you multiply two numbers and you get a negative number, if you took those same two numbers and you divided it, they're always going to be negative, because a negative times a positive is a negative. Those same two numbers, doesn't matter. It wouldn't matter if this one was the negative. It wouldn't matter. You'd still get a negative. So always. This is the formula. This was like one of our homework problems. This is the formula to change from Celsius to Fahrenheit. And it says, what is the temperature in degrees Fahrenheit? Although it said don't write it in your answer with Fahrenheit when it's negative 25 degrees Celsius. So we're going to say 9/5 times negative 25 over 1 plus 32, because that's going to give us our Fahrenheit. And then we're going to say, I like to cross reduce, so because you have to do multiplication first, then the last thing you do is add this. So when you're multiplying with fractions, I like to say divide by 5, 1, divide by 5, negative 5. You don't have to, but you'd have a little bit more reducing. So then we say 9 times negative 5 is negative 45 plus 32. We have 45 negatives and 32 positives, so we have more negatives than positive. How many more negatives do we have? 13 more negatives. Okay, so you just should have written negative 13. The answer really is negative 13 degrees Fahrenheit, but it told you just for the sake of easiness in writing in, not to write the units. Okay, it's which one is the better deal, and I made these very easy for you to divide. 2 tacos for $9 would be, each one is $4.50 per taco. 7 tacos for 28. Well, 28 divided by 7. 28 divided by 7 is $4 per taco, and 22 divided by 4. 22 divided by 4 would be $5 and something, over $5. Each one of these would be over $5. So 7 tacos for $28 would be the cheapest, would be the best deal based on price. Okay, this says if x is 3/5, and we're going to sub that in there, and y is negative 2/10, then I have 3/5 over negative 2/10. I can write that sideways to make that much easier. And if you want, you could even reduce that fraction right now if you would like. You don't have to, but you can. So that would be 3/5 times 10 over negative 2, because when you divide with a fraction, you flip the second fraction, or take the reciprocal, divide by 5, and we get 6 over negative 2, which equals negative 3. This one, the tricky part about when we substitute a negative number into a variable, you have to put it into parentheses. Okay, minus b is 4, so 4 to the third minus 2 times negative 2. So then we'll do our exponents first. So negative 2, you had to put it, every time you put a negative number, this came straight out of our notes for 1, 2. When you put a negative number in for a variable, you have to put in parentheses. So negative 2 in parentheses squared is 4 minus 64. I did my exponents first. Then I can do minus 2 times negative 2 is negative 4. So then we have minus negative 4 is 64. Add a line, changes sign. 64 plus 4 is 68. And then we have 4 minus 68. So 4 minus 68, think of add a line, changes sign. I have 68 negatives and 4 positives. That would leave me with 64 negatives. Okay, this one, it says a number line is shown. The numbers 0 and 1 are marked on the line, and it was much bigger. When it was on the quizzes, this was much bigger, as are 2 numbers x and y. So you see there's 0, there's negative 1. So we see this kind of distance right here. This looks like an even smaller distance, right? So the distance between negative 1 and y isn't as big as the distance here. So y cannot even be negative 2. Right? It's probably like negative 1.5, if I had to guess. Now look at this. Look at this distance all the way over here, this x. Like if I take this distance here, that would be like 1. That would be like 2. So this is maybe like 2.5 or maybe like 2.25. Even if you called it 2, you'd be able to simplify each one of these. Okay, so it says select all of the expressions that result in a negative value. Okay, so if you called, let's say you called it x is 2. I think it's a little more than 2, but let's just say you called it 2. Then you'd say 2 minus, and if y is negative 1.5, it'd be negative 1.5. That would be add a line, change a sign. That would be positive. So not that. This one, it says x plus y. Let's say x was 2 and y was negative 1.5. You'd get 0.5. So not that one. This one, y would be negative 1.5 minus, let's say that was 2, or even if you did 2 and 2.25 or 2.5, either one, that would be negative 3.5. So that's definitely a negative. This one, x minus 4. So if you said x was 2, or even if you said x was 2.25 or 2.5, 2 minus 4, that's clearly negative. Okay. This one, negative y. Well, if y is negative 1.5 and then there's a negative on the outside, then you'd have two negatives that would make it positive. So only this, only this one and this one. Okay, and that's with me making kind of just guesstimates on what x and y are, but whatever your close guesstimate would make, there'd only be b and e would make those negative. Okay, 15. Select all below that are an example of the commutative property. Commutative property means there has to be an order change. And this says the commutative property of addition. So 4 plus 6, 6 plus 4. That's an order change. And that does equal. This 2 plus negative 2 equals 0. No, that's the inverse property of addition. This 4 plus 0 equals 4. No, that's the identity property. This 3, 4, 7. 3, 4, 7. Okay, so that is the, oh no, there was, oh, I started to pick that. There's no order change. 3, 4, 7, 3, 4, 7. There's no order change. There's actually a grouping change. There's a 4 and a 7 in the parentheses, and that has a 3 and a 4. So that's actually the associative property. This one, I have A, B, C, C, B, A. I have an order change. So that's commutative. Simplify the expression below. The negative is not in parentheses, so that is 9 times 9 equals 81. Then times the negative, that would be negative 81. So if the negative was in parentheses, then that would be negative 9 times negative 9 is 81. But the whole thing that I was testing there is you got to know the difference of when the negative is and isn't in parentheses. Okay, select all below that are an example of the identity. So a number, so multiplication or addition, a number stays itself. It starts itself and it keeps its identity. So this, does 5 keep its identity there? Nope, that's the inverse property of multiplication. Does a 2 keep its identity by multiplying a 1? Yes, it does. Does a 4 keep its identity by adding 0? Yes, it does. Does a 3 keep its identity? Nope, that's the inverse property of addition. Does a 5 keep its identity? Nope, that's the commutative property of multiplication. This, select all apply, they're an example of the zero product. Product means multiply. Multiply, and all it means is any number multiplied by 0 equals 0. So here's a number multiplied by 0 to equal 0. This isn't multiplying 0, and it doesn't even equal 0. This is dividing 0, but when you divide 0, you don't equal 0, you equal undefined. This isn't multiplying by 0. This is something that equals 0, which means that is the, that's taking a number and adding the opposite. That's the inverse property of addition. It says simplify this below. Since you can't add what's in the parentheses, the only thing you can do is the distributive property of multiplication, and you'd get negative 24x plus 20. This one, when you have a fraction under a radical, you can separate it to the numerator and denominator to get 4/7. The square root of 16 is 4, because 4 times 4 is 16. The square root of 49 is 7, because 7 times 7 is 49. Simplify the expression below. So I'm looking for like terms. So 7x squared and 4x squared is 11x 11x squared. This is the only one that even has an 11x squared, because this you don't add you don't add exponents, and then nothing to add to the negative 9x, so there's that. Nothing to add to the negative 5, so there's that. Simplify this expression. You cannot distribute because exponents come before multiply. So I gave you this specific example in the notes saying nope, 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 you cannot distribute. You have to follow order of operations. So the first thing you do is you say 8 minus 5 is 3. Then 3 to the third power times 2. I always like to rewrite, divided by 4. Then the next thing you do is 3 divided by 3. 3 to the third power, not 3 divided by 3. 3 to the third power, which is 3 times 3 times 3, which is 9 times 3. It's 27 times 2 plus 16 divided by 4. 27 times 2, you have to do multiplication, is 54, plus 16 divided by 4 is 4. Then the very last thing you do is add to get 58. 23. To simplify this, you use the distributive property of division, or if you want to think of it like this, you can take it out of the fraction, but if you take two parts out of the fraction, they have to go in parentheses, so then the 8 divides each one, or you could say 20x over 8 plus 4 over 8. This one's going to reduce to 1/2. This I could divide by 4 to get 5 over 2, and that's x. So that would be this one right here. That's the division, or the distributive property of division. True or false? Subtraction is associative. Associative means the grouping changes on one side. That's definitely false. I'm not going to pick this one with true. But why is it true? Well, this shows an order change. Associative is a grouping change. So even though this says false, it's not this, because this shows commutative. So definitely not that one. It's false because subtraction is only commutative. No, subtraction is not commutative, so not this. This shows the order doesn't change. 6, 4, 2. 6, 4, 2. But this has the grouping around 6 and 4, so that would be 2 minus 2 is 0. This one changed the grouping to 4 and 2, so that would be 6 minus 2 is 4, and clearly 0 doesn't equal 4. So there's a counter example. Okay, A over B equals 0. What does A have to be? What does B have to be? Well, B definitely cannot be 0. We cannot, if we have a 0 in a denominator, remember that's like no, that's undefined. No 0 in a denominator. So B definitely cannot be 0, because if B equaled 0, then we wouldn't have 0. So what does A have to be? Okay, so definitely not that, because we don't want B to equal 0. We want B not to equal 0. What does A have to be in order for the answer to equal 0? A has to equal 0. Not any number. If it's any number, then we won't equal 0. Not 0. No, if it's not 0, then we won't equal 0. The only way that A over B equals 0 is if A equals 0 and B does not equal 0. As long as there's a 0 in a numerator, then the answer is going to equal 0. 26. Select all below that are examples of a square root. Okay, so I see a square root on every single one of these. That is rational, meaning the answer can be written in its exact fraction. Well, we cannot take the square root of a negative number. That would be, we say what we say is there's no real solution. So it cannot be that one. No negatives under the square root. This one right here equals 5 over 9. 5 over 9 is rational, so I'll pick that one. This equals 8, and 8 can be written as a fraction, so that's rational. I do radical 36 is 6, square root of 36 is 6, then the times the negative on the outside, that can be written as a fraction, so that one. The square root of 13, we could estimate that into like 3 point something, but that can't be put into an exact fraction. That's the definition of irrational. So it's only this one, and this one. All three of those can be put into a fraction. This one cannot, because you can't have a negative under a radical. All right, let's simplify this. We just add a line, change the sign. So we have 15 negatives plus 32 negatives. That's going to give us 48, goofer. That's going to give me 47 negatives, right? If I have 15 negatives and 32 negatives, that's going to give me 47 negatives. Estimate the square root to the nearest tenth. So I could say 52, that's between 49 and 64, so that's between 7 and 8. So it's a number between 7 and 8, so 7 point something. So definitely not this one. Okay, and then it's like 7 and 3 over, because the distance the distance from 49 is 3. It went 3 units. If it went the full distance, if it had gone the full distance from 7 to 8, that would have been 15. Okay, 15 is like 3 over 15 if I divide by 3 and divide by 3. Now this is of course an estimate because irrational numbers can't be put into a fraction, so we call it an estimate fraction. That'd be 1/5. 1/5 is approximately 0.2. So that would be this one right here, or you could divide that, or you could have divided that. Either way, you'd get 0.2. Okay, that is every single question. You can see kind of at the bottom, this, if you want to pause this, that kind of gives you all the answers kind of in one. So you can always hang back at any of our Google Meets to ask me any of these questions. You're also free to email me if you want me to send you the report of what you put for your answers.